Hello. In this session, we're going to talk about optimal start, which is a cost-saving strategy implemented by automated logic. Now, optimal start is oftentimes called morning warm-up, and it's designed to prevent the following problem. Let's say that we have this building here, and it's scheduled to be occupied between 8 o'clock in the morning and 5 o'clock in the evening. Well, that means we've created a schedule that says go occupied at 8 in the morning and go unoccupied at 5. Now suppose it's winter time and it gets very cold outside. There's a potential problem that's going to arise, and we'll talk about that problem right now. I'm going to navigate to the office area. I'm going to look at the logic page. Let's look at this set point microblock. Between 8 o'clock in the morning and 5 o'clock in the afternoon, we're going to maintain 71 to 74 degrees. But between 5 o'clock in the evening and 8 in the morning, we want to relax that set point band so that we're not wasting energy. We're not going to call for heating unless it gets below 60 degrees. Well, in the wintertime, it's very likely that that zone is going to drift far below the 71 degrees. So let's say in our example, it gets down to 63 degrees. If people come in the morning, the building goes occupied at 8, and it's 63 degrees in the zone. Of course they're going to be uncomfortable. Of course they're going to complain. And so what used to happen in the old days is that people would say, fine, I can't take the complaints in the morning. Let's just schedule the whole building to go occupied at 6 in the morning. We'll heat the entire building. By 8 o'clock, we'll have heated the building up. The people who arrive, they won't complain. I won't get any phone calls. Everyone's happy. Well, of course, that wastes a lot of energy between 6 o'clock in the morning and 8 o'clock in the morning because we're running with no one in the building and we're just needlessly heating these zones. It would be nice if we had some solution that would sort of anticipate when the people were going to arrive and heat as needed and only as needed in order to make sure that when they get there, it's between 71 and 74 degrees in the zone. And that's what optimal start gives us. Optimal start is simply a means of the system saying, listen, I know in this particular zone at 8 o'clock in the morning, I need to maintain a set point between 71 and 74. Let me make sure I'm there when the people arrive, but not waste a lot of energy doing it. But how does optimal start work? Well, first of all, let's mention that we're in a set point microblock right now, but any of the web control set point microblocks have optimal start built into them. This optimal start functionality will use a variety of factors to determine when it should start heating in order to make sure that we're 71 to 74 when the people arrive. Let's talk about what those variables are right now. Well, first of all, the set point microblock needs to know how warm it is in the zone, so it's going to look at the zone temperature. It needs to know how cold it is outside, so it's going to look at the outside air temperature, and that's going to be sent from the sensor outside, of course. But it also needs to know at what rate can it heat the zone, and that's called the capacity. So right here, the engineer who created this system said, I know this zone can heat and cool at 5 degrees an hour, and that's typically found in the engineering design specification. So the engineer said, okay, this particular zone has the ability to heat at 5 degrees an hour. Finally, we have design temperatures, and these are entered by the engineer, same person who did the job, and they're going to get that from ASHRAE. And this is, of course, going to differ by geographic location. But those 6 variables, the 2 here, design temperatures, capacities, outside air, and zone temperature, are going to be used by this microblock. And behind the scenes, it's going to start calculating, hey, what do I need to do to make sure I'm within occupied set points when they arrive? I'm going to Alt-Tab to the help files. We're going to take a look at how this happens. Now, there's this kind of complicated formula here, but we don't need to worry about that. Let's just look at the graph right now. This is on our unoccupied set points, and this is our zone temperature. Okay, and this is happening in the evening. The microblock starts saying, you know what? I know that I need to be at 71 degrees by the time people arrive. I'm going to take those variables, and I'm going to start recalculating what my new set point should be as I approach 8 o'clock in the morning. And the reason I'm going to do that is I know what my capacity is, and I'll never make it if it's 63 degrees in the zone and I just simply turn everything on at 8 o'clock in the morning. As it's recalculating this set point, the zone temperature is going to be dropping throughout the evening, and eventually it's going to cross and we'll send a heating request out. And that's why sometimes in the morning you'll come in and your entire building will be gray for unoccupied, but a few zones might be a different color because they've actually made a call for heating and cooling, anticipating that they'll need to be within a certain band when they go occupied. So all we're doing is recalculating set points and letting them cross the zone temperature and then make our call for heating. And it's that simple. And what's nice about it is you don't need to know this crazy formula because the microblock knows the formula for you. And using this methodology, we're able to reach the set point that we want without scheduling the whole building. Oftentimes, a lot of the zones, especially in the interior building, won't even need to make a call for heating before 8 o'clock in the morning. So you're not wasting energy there. Sometimes you don't have to make a call for heating until 7:30, so you're not scheduling from 6 o'clock and wasting energy either. So this is the efficiencies that we gain from using Optimal Start. Now, we have some advanced functionality in some of our set point microblocks called Learning Adaptive Optimal Start. Notice that this one has Learning Adaptive Optimal Start. Not all of our set point microblocks have that. That's a choice the engineer can make. And the concept behind this is pretty simple. We're going to do the following. Let's say it's 8 o'clock in the morning, Optimal Start is kicked in, but we haven't made it. In other words, it's still a little cold in the zone. When that zone goes occupied, it happens to be light blue. We're a little bit outside of the band that we want. So in this case, let's say that we happen to be at 70 degrees. Well, if we're using Learning Adaptive Optimal Start, the microblock will say, I was light blue when we went occupied. Using this number that was entered by the engineer, I'm going to change my capacity for them and lower it by 0.06 because I didn't make it last night. And because I have less of a capacity to heat the zone, I'll probably have to kick in a little earlier tomorrow than I did this morning. That way, I can make sure I'm green when everyone goes occupied. Now, notice that we have the same thing on the cooling side. In other words, I was yellow when I got in, when they went occupied rather in the morning. So I would do the same thing here. I would simply adjust my capacity and I would know I can't cool as quickly as I thought I could, so I better start a little earlier tomorrow. Now you may be wondering, why would we have one for the green band? Well, if we get there at 8 o'clock in the morning, the zone is green, I might have started a little early. I might have wasted some energy. So what I would do is, I would simply go, I can heat a little more than I thought. So I'm going to start a little later with my morning warm-up so that I can save energy. And this happens every day, it gets recalculated. And in this way, we can use the least amount of energy but maintain the highest comfort level. Now, as I said, this is an option that comes with certain microblocks, but you'll notice we have this input right here called Learning Inhibit, LRNI rather, and we can actually attach a microblock to it, and when this microblock is triggered on, it will not learn. So you have the ability to disable learning, and you might do this when, let's say, you're working on the building, and you don't want it to learn because there's unusual things happening, like you have windows open, for instance, and we're radically altering the normal conditions of the zone. If we're doing something like that, I can simply enable this particular input, and we'll temporarily disable our learning until such time as we've gotten our situation in the building sorted out, and then we can go back to learning the next day by turning this back on. And we'll finish the discussion by suggesting that you leave Learning Adaptive enabled for the first year of operation until such time as your mechanical system is settled in, and then simply disable it, because by then, your Learning Adaptive Optimal Start should be optimal.